Statistical study of relationship and comparison of average monthly temperature in nCoV-SARS-2, a case study of India. Abstract. In this study we employed statistical methods to relate and make comparison between monthly average temperature and number of confirmed cases for COVID-19 disease. Our studio were used to achieve the results. We extracted our data for the analysis from the Ministry of Health and Family Welfare Government of India for the cumulative confirmed cases of nCoV-SARS-2. The average monthly temperature from March 1st to May 31st, 2020 were also extracted via internet from current results weather and science facts for Indian weather. The descriptive analysis of the generated data was presented graphically. Our findings show that the average temperature so far has no effect on the number of nCoV-SARS-2 in all the 4 regions of India. In fact, number of cases are still in the rise with daily increase. Keywords: temperature, COVID-19, t-test, correlation, R programming. 1. Introduction. As a result of high rate of spread of COVID-19, serious attention has been given to study on rate of the pandemic, transmission ways, methods of prevention and how the virus will survive when exposed to certain amount of temperature. The activities of the virus in association with environmental features is critical. 1. The nCoV-SARS-2 infection 2019 or COVID-19 pandemic has turned out to be a very serious health issue of concern by government and general public. The newness of the syndrome encourages an investigation for thoughtful of how natural dynamics influence the spread and existence of the disease. Many researchers have tried vigorously in finding a connection between temperature and COVID-19 number of confirmed cases. But there is no exact study for the 4 regions of India. Kazella et al. 2020 performed a study on the novel nCoV-SARS-2 structure. Their examination revealed that the disease fits to the family of single-stranded RNA viruses, plus ssRNA, which has a length of about 30 kb in an envelope with spear structures, and they verified the sensitivity of the virus to UV light and temperature. 2. Piraus et al. 2020 studied the relationship between environmental features and the number of confirmed cases of coronavirus using the artificial intelligence techniques. The findings of this investigation placed indication on the role of weather conditions on the pandemic rate. 3. Chen et al. 2020 established a time-dependent mathematical model for the estimation of the total number of confirmed cases. 4. Examination of the prior studies shows that a further investigation about the consequences of ecological factors on the nCoV-SARS-2 is required. Since some of the earlier studies have indicated the influence of weather situations, particularly temperature, on COVID-19. The coronavirus disease 2019, COVID-19, is steady in feces at room temperature for a minimum of 1 to 2 days, and it can be steady also in an infected person for up to 4 days. Thermal heat at 56.0 C destroys the COVID-19 at about 10,000 units per 0.25 HRS. Thus, temperature is a vital feature in existence of COVID-19 disease. 5. The objective of this study is to determine if there exists a significant relationship between temperature and COVID-19 confirmed cases from March to May 2020 as well as their comparison for the 4 regions of India. In this study we employed statistical methods to relate and make comparison between temperature and number of confirmed case for COVID-19 disease. T-test was used for comparison and correlation analysis have been used to find if significant relationship exists. Study scope. The scope of this study covers only the 4 regions of India, western, northern, southern and eastern regions. Below are the maps of India showing the location of each region. 6. We consider their average monthly temperature and the cumulative confirmed cases of nCoV-SARS-2 from the early month of March to the end of May, 2020. 2. Method. 2.1 Techniques of t-test statistic. The t-test statistic is among the type of inferential statistical techniques used in determining if significant differences exist among the means of 2 sets of variables, which may be associated in certain structures. A t-test is applied as a hypothesis testing instrument, which permits analysis of a guess suitable to a population. A t-test, TT, gazes at the test statistic, the t-distribution outcomes, and the degrees of freedom, DF, to ascertain the statistical significance adequacy. 7. The statistical procedure for testing hypothesis on 2 differences means, for normality of 2 distributions such that variance 1, and variance 2, are not known. A t-test statistics is appropriate to test our claim and assumption. We follow the following steps with an assumption that the 2 variances of the given dual normal distribution are equal and unknown. 12. 21. 22. 5. Decision in conclusion. The final steps is to take decision based upon the step 3 and 4 and draw a statistical conclusion for the users and policymaker. 2.2 Techniques of correlation analysis. A correlation is a statistical term refers to statistical tools that aimed in helping researcher to measure and analyze extent of or degree of association between 2 variables. Usually, correlation investigation deals with the relationship between 2 or more variables. The mathematical and statistical formula for measuring such relationship and its significance is as follows. 1122211 It is usually useful to test significance of the true correlation value through the application and formulating statistical hypothesis. The used hypothesis for the significance of the correlation estimate is versus 00H equals, and the test statistic applied is 10H. The decision rule is that the null hypothesis should be rejected if or otherwise. 8. 21 count equals 2,2 count dash. 2.3 Data analysis. In this study, we applied our studio to estimate the relationship and its significance for the 4 regions of India. We extracted our data for the analysis from the Ministry of Health and Family Welfare Government of India for the cumulative confirmed cases of nCoV-SARS-2. The average monthly temperature from March 1st to May 31st, 2020 were also extracted via internet from current results weather and science facts for Indian weather. 9 to 11. The descriptive analysis of the generated data were presented graphically. Comparable to standard values of correlation coefficients varies in between inclusive. Our p-values shows a non-significant correlation between the study variables. We further employ the 2 independent sample t-test which gives the comparison of means of our study variables. 11R. 3 results and discussion. Figure 1a is a multiple bar chart of eastern regional state of India. This chart clearly depicts the average temperature and cumulative cases of nCoV-SARS-2 in hundreds of the region. The chart practically shows higher temperature amount in the month of May while in April the temperature value is moderate but in March there is low temperature in all the state of this region. West Bengal record higher cases of nCoV-SARS-2 but its temperature value remained almost similar to all other states. States like Meghalaya, Nagaland, Tripura, Assam, and Odisha have recorded lowest number of confirmed cases. In summary, higher, moderate and low average temperature value have no correlation with an increase or decrease of nCoV-SARS-2 cases. Even though relationship may seem to exist in one way or the other, but it might likely be insignificant and inversely correlated. The line graph in figure 1b shows also same result as depicted by figure 2a and 2b depicts the relationship between the average temperature recorded in the month of March, April, and May with cumulative number of COVID-19 cases in the said months respectively for the southern region of India. Tamil Nadu has the highest number of cases with relatively increase in the average temperature from March to May 2020, while Andaman and Nicobar, Puducherry recorded very small number of confirmed cases and Lakshadweep reported zero number of confirmed case. This may attributed to so many factors including but not limited to, adherence to the government restriction of movement, advices from health personnel such as, washing of hands with sanitizer and social distancing. Our findings revealed that there is no significant relationship with temperature and confirmed number of cases for coronavirus. Fig 2a. A multiple bar chart of southern India. Figure 3a is a multiple bar chart of western regional states of India. This chart visibly shows the average temperature and cumulative cases of COVID-19 in multiple of hundreds of the western region. The chart virtually indicates higher magnitude of temperature in the month of May, while in April the temperature value is reasonable moderate, but in March the temperature is slightly lower than that of April in all the state of the region. Maharashtra reported higher number of confirmed cases of coronavirus, but the magnitude. Fig 2b, a line graph of southern India of its temperature were almost same as other states, then followed by Gujarat with second highest number of cases, and Rajasthan is the third state, while Goa has the least number of cases in the region. In summary, our findings shows that average monthly temperature value have no correlation with an increase or decrease of cumulative number of COVID-19. The line graph in figure 3b shows also same result as depicted by figure 3a. Figure 4a and 4b are multiple bar chart and line graph respectively. The figures are showing northern Indian region, depicting each state in the region with average temperature for 3 months, March, April, and May, along with daily cumulative number of confirmed cases. The vertical axis is in multiple of hundreds for daily cumulative number of confirmed cases only. As shown in the figures, there are 9 states in the region. The average temperature for April and May is almost same and is higher than that of March for all the states. It was observed that the highest average temperature in the region is 30°C from March to May. The lowest temperature was found to be in Jammu and Kashmir, followed by Himachal Pradesh, though Himachal Pradesh have less number of confirmed cases as Jammu and Kashmir do have. Though, looking at the line graph of the northern region, it shows similar patterns for all the 3 months average temperature used in the research. Delhi have the highest number of the daily cumulative number of confirmed cases as shown from both figures 4a and 4b. On the other hand, Chandigarh have the lowest cases. Uttar Pradesh and Madhya Pradesh have almost same. Chandigarh and Uttarakhand have shown almost similar patterns of the average temperature and the number of confirmed cases. Our findings shows that the highest number of cases was not recorded in the state with highest average temperature value. The lowest number of confirmed cases was not recorded in the state with lowest average temperature in the northern region. So as the region concerned, temperature has no contribution in the spread of the virus. The table above gives the summary of statistical analysis of our 4 study regions of India. From the table, it is shown that eastern region have a strong correlation values, though extent of the relationship is not significant because the p-values are greater than the 5% level of significance. We further analyzed our data using t-test and the results confirmed that the average temperature cannot be compared with the cumulative number of COVID-19 confirmed cases in the eastern region of India. Likewise, the relationship of average temperature and cumulative number of COVID-19 confirmed cases were also shown in the table 1 for the southern region of India. Our findings indicate a weak correlation between our study variables. The t-test analysis shows that the variables average are incompatible for comparison within the statistical probability. Similarly, the relationship in western region are weak but with negative correlation, which implies decrease in one variable lead to the decrease in another, but with statistics confidence level, this relationship revealed to be insignificant. Applying t-test for comparison indicates that the two variables also cannot be compared statistically, which counter-argued the claim, increase in temperature may decrease the number of COVID-19 cases. Lastly, in northern region, a weakly relationship was reported in the month of March, while in the months of April and May a strong relationship was indicated. Same results was recorded as the other 3 regions when t-test was applied for the test of comparison. The strong relationship in eastern India were attributed to high cumulative number of COVID-19 confirmed cases and the average temperature. But still the strong relationship has no effect to buttress the saying that COVID-19 cases decrease with increasing temperature. The negative relationship witnessed in western region is due to the low cumulative number of COVID-19. Though significant relationship may exist when the magnitude of the temperature reaches 60°C, which may likely not be viable in India, because the highest average value of the temperature is usually recorded in the month of May. Conclusion. Our findings show that the average temperature so far has no effect on the number of nCoV-SARS-2 in all the 4 regions of India. In fact, number of cases are still in the rise with daily increase. The highest number of cases was not recorded in the state with highest average temperature value. The state with lowest average temperature also has not reported the least number of confirmed cases. This has also confirmed our study hypothesis.